Hello dear students. In previous class we have seen about partial sum and sigma notation. Today we are going to see about sum of arithmetic and geometric progression. After revising this lesson, you are expected to compute partial sum of arithmetic and geometric progression. So let's continue to the lesson. Sum of arithmetic progression. Simply before putting the formula how to evaluate sum of arithmetic progression, let's see how the formula derived. One day Gauss teacher asked the students to add the numbers from 1 up to 100, and Gauss come up with the answer within a very short time, and the teacher amazed with his answer and asked how he do it. Let's see how Gauss did the answer. Look how Gauss did it. The sum of the first 100 numbers is given as it is s equal to 1 plus 2 plus 3 plus it goes on up to 100. This is the sum of the first 100 natural numbers. So again he add these twice by starting from 100 to 1. So he put like this: 100 plus 99 plus 98 plus it goes on up to 1, and then add this. The sum of this will be just add these twice. The sum will be these twice of the sum of the first 100 numbers, natural numbers. So this is equal to the sum of these two, it is 101. This also it is 101 plus all terms are 101. It goes on like this up to it is 101. So simply we can add these numbers easily. We have 100 101s. The terms are 1, 2, 3, 100 terms. These 100 ones are 100. Therefore, twice of the sum will be equals to 100 times 101. This is twice sum. So the sum will be, you divide by 2 and you get this one. The sum is equal to, it is 100 divided by 2, 50 times 101 will be, it is 50. So this is how Gauss did the answer. So how this technique was developed to a formula, let's see that. Assume this one is an arithmetic progression. So to find the sum, let's follow the technique Gauss did. So the sum of n terms of this arithmetic progression Sn is equal to, it is a1 plus a2 plus an. And so to find or to develop the formula, let's add this in reverse order too. So Sn is equal to, it is start from the nth term an plus this one, it is the next term, is this an minus 1 term plus the first term. So when you add this, you get the following. This one is this twice of the sum of n terms of an arithmetic progression. This is equal to the sum of the two, it is a1 plus an, plus the sum of these two, it is a2 plus an minus 1 is also, it is a1 plus an. Let's see this. A2 plus a2 plus an minus 1. A2 plus an minus 1. To find this, a2 means it is the first term plus d. This it is a2. And an minus 1 is, it is, we can apply the formula an is equal to this an minus 1 plus d. Therefore, an minus 1 is it is an minus d. Therefore, from this you can cancel these two. The sum will be it is a1 plus an. Therefore, the sum of the two is also it is a1 plus it is an plus the sum of this, also the sum of these two is also it is a1 plus an. Therefore, you can see all the terms, the sum of the terms are a1 plus an, a1 plus an, a1 plus an. We have how many a1 plus an? We have n a1 plus an, because the terms, if you count the terms a1, a2, a3, a4, an, so we have n terms here. So these sums are n. Therefore, you can write this in this form: twice of Sn, this is equal to n times a1 plus n times a1 plus an. Therefore, divide this by 2, you get that the sum of n terms of an arithmetic progression is equal to, dividing by 2, it's n over 2 into a1 plus an. So this is a formula, or we can further rewrite this in other form. Sn is equal to, it is n over 2 into a1 plus, I hope you remember the general term, an is equal to a1 plus n minus 1 times the difference. So the nth term is equal to this a1 plus n minus 1 times the common difference. Therefore, this becomes Sn, the sum of n terms of an arithmetic progression is given by n over 2 into a1 plus a1 is twice of a1 plus n minus 1 times the common difference. So this is the formula to evaluate the sum of n terms of an arithmetic progressions. So this is a formula, we derived it. So as the sum of n terms of an arithmetic progression, it is given by n over 2 times twice of a1 plus n minus 1 times difference. So let's proceed to example. Now let's see the first example. In this example, find the sum of S8, or the sum of the eighth term of the arithmetic sequence whose first term is 4, and the common difference is it is 5 here. That is, we are asked to find S8. A1 is given. It is A1 is how much? It is 4. A1 is 4, and the common difference it is 5. We need to find the sum of the eighth term. So let's see how to do this. So applying this formula, Sn is equal to n over 2 into twice of a1 plus n minus 1 times the difference. You get this one. So the sum of eighth term is 8. You put 8 in place of n, 8 over 2 into twice of the first term is 4 plus n is 8, and 8 minus 1 times the common difference is 5. So this is the sum of the first 8 terms. So simplifying this, you get this one. This is 4, 8. 8 minus 1, 7 times 5, 35. So the final answer will be 172. Let's proceed to another example. Example 2 says here, find the sum of the first 20 terms of a sequence whose general term is given here. The general term is this: an is equals to 4n. You are asked to find the sum of the first 20 terms. So to do this, first let's try to list some of the elements of this sequence. The first term of this sequence, when you put 1 here, you get 4, and the second term 4 times 2 is 8, the third term 12. It goes on like this. So from this you can see that the first term a1, is it is 4, and the common difference of this arithmetic progression is it is 4, and we are asked to find what? We are asked to find the sum of the first 20 terms. So applying the formula, we will have this one. Sn is a formula like this. So putting the numbers in the formula, you will have this one. Sum of 20 term is 20, n is 20, 20 over 2 times twice of 4 plus n is 20 minus 1 times 4. Therefore, this will be this 10 times. The result is this 8 plus 7, 6. The final answer will be this 840. Now let's continue to another example 3. So here, if the nth partial sum of an arithmetic sequence is given to be twice of n squared, and you are asked to find the nth term of this an arithmetic sequence, the formula for nth term. So here Scn is given. Scn, the sum of nth terms of an arithmetic progression, it is given to be, it is 2n squared. So you are asked to find what? The formula for nth term of this arithmetic sequence. So to evaluate this, nth term means the sum of nth terms of the sequence minus the sum of n minus 1 terms of the sequence. If you look this one, the sum of nth term minus sum of n minus 1 term, this n minus 1 term cancels the remaining n minus 1 term. You will have only nth term. So an is given by this form. Therefore, this means Sn, the second one is this Sn minus 1. Therefore, you will have this one. The nth term is given by, this is the sum of the first n term sequence minus the other one is the sum of n minus 1 terms. So an is equal to Sn is given, it is 2n squared. So 2n squared minus Sn minus 1 means simply you can put n minus 1 here. So 2 times n minus 1 squared. Therefore, simplifying this, you'll have this one, 2n squared minus twice of this is this n squared minus 2n plus 1. So distributing 2, and you'll have this one, 2n squared minus twice of n squared. This becomes plus 4n. This is this minus 2. So simplifying these two, just cancelling this, you will have 4n minus 2. Therefore, the nth term of this an arithmetic progression is it is 4n minus 2. So let's proceed to another example. Example 4. Example 4 says here, find the sum of the integers between 301 and 400 inclusive that are multiples of 4. That means the numbers which are divisible by 4. So to find the sum of this, you have to first list the terms. You have to list the terms. That means the terms that are divisible by numbers that are divisible by 4, which are found between 301 and 400, inclusive. So let's see the numbers. So the terms of the sequence which are divisible by 4 are the first term which is divisible in this interval, which is divisible by 4 is 304. 301 is not divisible by 4. So the number next to this, the number which is divisible by 4 is this 304. The next one is 308, and it goes on up to 400. We included 400 here. The question says you can include it is inclusive. It's inclusive. We can include 301 and 400, not only the numbers which are found between these two. But 301 is not a multiple of 4, so we exclude that. So the terms of the sequence are 304, 308, and 400. So we need to find the sum of these terms. To find the sum, we have the first term, it is 304, and the common difference is this 4. And we don't know the term in which term this 400 belongs. Is it in 1 second, in third, fourth? So we need to find that. So assume this 400 is on nth term, so an is equals to 400. After that, we need to find n, and then after finding n, we'll proceed to evaluate Sn. So let's continue. I hope you remember this formula. The nth term of an arithmetic progression is given by a1 plus n minus 1 times d. So from this, nth term is this 400. 400 is equals to, the first term is this 304 plus n minus 1 times d. If you multiply this by 4, you get this result. It is 4n minus 4. So from this, 4n is equal to this 300, shift to the other side, 400 minus 300 is this 100. So dividing this by 4, you get n is 25. So the number of terms, these are 25 terms. We have 25 terms. So we are asked to find the sum of these 25 terms. So applying the formula, this formula, you will have this one, S25, this is equal to 25 over 2 times twice of a1. a1, the first term is this 304, twice of a1 plus n is this 25 minus 1. The common difference is 4. So the result will be this. When you simplify this, you get 8,800. So you can check the numerical value at the end of the lesson or the lecture. So let's proceed to the other part. Example 5, let's see example 5. Every day a person saves 5 cents more. It saves 5 cents more than the amount he saved on the previous day. So his target is to save the total amount of this much cents, 3,225 cents, by the end of 30 days. So the question is, how much must be the starting saving to meet the target? This is the question. So to solve this, we need to find the first term, the common difference, and here the sum of the nth term is given 3,225. So let's list these values. This 3,225 is the sum of money he saved on 30 days. So that means S30 is this 3,225. Here the amount of saving is 5 cents more than the amount he saved on a previous day. For example, if he saved 10 cents today, on the next day he saves what? What amount? 5 more, 15. On the next day he saves, it is 20. So from this you can see that the common difference is 5. Therefore, the common difference is 5. So we are asked to find the first term a1. So applying the formula, we can find a1. This is a formula, and so the sum of certain terms is given. It is 3,225. This is equal to n is 30, so 30 over 2 times twice of a1 plus n is 30, 30 minus 1, the common difference we have found 5. So this is the answer. So let's proceed. Let's simplify it. This is 3,225. This one is 15. Divide by 15 both sides. You get this one is equal to twice of a1. This result is 145. So to find twice of a1, or to find a1 or twice of a1, this is equal to this. This result is this 215 minus, just putting this to the side, minus 145. So the result will be this twice of 1 is equal to 70. Divided by 2, you get 35. So he started saving from 35 cents. This is the answer. So let's continue to the other part. Now sum of geometric progression. The next part is sum of the terms of geometric progression. To find the sum of terms of geometric progression, let's see how the formula is derived. So look, assume this Gn, assume this Gn is its a geometric progression, and the sum of n terms of this geometric progression is equal to this, the first term plus the second term. The second term, I can write second term by this formula G1 times R, and the third term, it is, I can write the third term in this form, g1 times r squared, third term, and the fourth term, and it goes on like this, plus g1 times the nth term is, it is g1 times r the power of n minus 1. So this is it. Now again multiply this by r, by common ratio, r times Sn. R times Sn, this equal to, you multiply the whole part by r, so you have this one, g1 times r, plus here this becomes this g1 times r squared, plus this becomes this g1 times r cubed, g1 times r cubed, plus the last term will be this g1 times r the power of n, r the power of n minus 1 times r is this, r the power of n. So next to this, simply subtract from this part, subtract this part. So you'll have this one, Sn minus r times Sn is equal to, when you subtract this whole part becomes negative. So this minus g1, all are negative. So this cancels with this one, this cancels with this one, and g1 times r is also there, and this g1 times r raised to n minus 1 cancels by g1 times r raised to n minus 1. There is in front of this there is g1 times r raised to n minus 1, so that cancels. Only the remaining part is this one and this, the whole part cancels. So you will have this answer, g1 minus, this is negative, you are subtracting, g1 minus g1 times r raised to n. So you can factor Sn here, Sn into 1 minus r. This is equal to, you can take g1 outside here, or you can factor g1. So you'll have this one, 1 minus r raised to n. So next, divide by 1 minus r. We divide this by 1 minus r for r is different from 1. For r different from 1, we can divide both sides by 1 minus r, by 1 minus r. So this cancels. The sum of n terms of this geometric progression is given by, it is g1 times 1 minus r raised to n over 1 minus r. This is a formula. By the way, we can rewrite this in this form. Let me write it here, g1 times g1 times 1 minus r raised to n over 1 minus r. This is the same as, you can take negative outside here and multiply on the numerator. You get this one, g1 times, it is r raised to n minus 1. When you multiply this by negative, you can reverse this too, over this becomes also this r minus 1. This is the formula to calculate the sum of n terms of geometric progression, where r is different from 1. This is the formula. If r is equal to 1, in that case all terms are the same. The first term g1, second term g1, third term g1. So for r is equal to 1, the sum of n terms of this progression will be this n times g1. Since all terms are the same, simply multiply by n. This is for r is equal to 1. So this is how the formula was derived. So this is a formula. Let Gn is a geometric progression with common ratio r. So the sum of the first n terms, Sn, is given by, we derive this formula, g1 times 1 minus r raised to n over 1 minus r, or you can write this g1 times, just reverse the two, simply it is r raised to n minus 1 over r minus 1 if r is different from 1. If it is r is 1, simply the sum of terms will be this n times g1. So let's apply this formula. through example. Let's see this example. Given the sequence 1, 3, 9, 27, it goes on like this. You are asked to find the sum of the 5 terms of this sequence. To find this, when you see the progression, it is a geometric progression because it has a common ratio 3 divided by 1 is 3, 9 divided by 3, 27 over 9 also 3. So this is a geometric sequence with first term 1 and the common ratio is 3, and you are asked to find the sum of the first 5 terms. So we are asked to find this. So applying the formula, using this formula, Sn is equal to G1 times R raised to n minus 1 over R minus 1. Just G1 is 1, R is 3. So putting these numbers on the formula, you will have this. S5 is equal to G1 is 1 times R is this 3, so for 5 minus 1 over 3 minus 1. When you validate this, you will have this 1. So the answer will be 242 over 2. This becomes this 121. So let's add one more example for this part. Example 2. We are asked to evaluate this. The sum of 1 over 2k, where k starts from 1 up to 10. To find the sum of this sequence, we need first to put the sum of the terms of this sequence. So let's see the terms of the sequence. The first term of this sequence is, you put 1 here, you get 1 over 2, it is 1 over 2. The second term, put 2 here, it is 1 over 2 squared, it's 1 over 4, and it goes on like this. So when you see the sequence, it is a geometric sequence with first term 1 over 2, and the common ratio, take the ratio of the two, 1 over 4 divided by 1 over 2, it is 1 over 2, and so on. So the common ratio is 1 over 2. We are asked to find S10. So using the formula, S10 is given as G1 times R raised to n minus 1 over R minus 1. So this equal to S10 is equal to G1 is 1 over 2, and R is also, it is 1 over 2, 1 over 2 to the power of 10 minus 1 over R 1 over 2 minus 1. So simplifying this, I can write this 1 over 2 in the form of 2 raised to negative 1, and the difference of this is also negative 1 over 2, negative 2 raised to minus 1. So this, I can write this to the power of negative 10. So to the power of negative 10 minus 1. You can cancel this 2, but negative is there. So put negative on the upper side, multiply it, you get this result. When you multiply this by negative, this negative multiplied above or the numerator. So when multiplied, this becomes positive, this becomes negative. The answer will be this 1 minus to the power of negative 10. I can leave the answer in this form. The answer will be this 1 minus to the power of negative 10. So this is, it is all about today's lesson. So I will give you exercise for you to try. Please try this exercise. So until next lecture class, goodbye everyone.